Using fluid layouts ensures that as screen sizes or orientations change, content will reflow or reconfigure along with it. That works seamlessly for content such as text, which naturally reflows along with its containing element. But what about content that is by default defined at a fixed size, such as images or other media? An image designed for a large desktop monitor is unlikely to fit into a layout designed for a 320-pixel wide smartphone. Likewise, images designed to accompany content on a mobile screen would probably look like thumbnails when viewed within desktop layouts. This means that in the best of circumstances, these images will look out of context and, in many cases, will break your carefully crafted responsive layouts. This problem underscores how important it is to find ways to make images and other media responsive. At first glance, you'd probably be tempted to say the solution is pretty simple. Just replace the fixed dimensions with relative measurements or percentages and then, boom, flexible responsive images. Well, unfortunately, it's just not that simple. Matt Wilcox recently called the issue surprisingly complex, and I'm inclined to agree with him. Currently, if you want to make images responsive, you do have a couple of options. First, you could simply do what we discussed earlier. Replace the fixed dimensions with percentages or relative units. You can even add a maximum width property to avoid scaling the image past its original size. To make the math of calculating image proportions a bit easier, you could also place the image in a flexible container and simply use a max width equals 100% property to constrain the image to the size of its container. Since this works with any element, you could use this with other fixed media assets such as flash or video as well. Well, that sounds easy enough, and it seems to work, so what are some of the issues with this technique? Well, Internet Explorer doesn't support maximum width, meaning you'll have to use a workaround to achieve the same effect. Also, you have to be careful when mixing width and maximum width properties. The width property explicitly sets the width of the element, while maximum width tells the element not to exceed a specific width. Those are not the same thing. Perhaps the biggest issue with this technique is one of size. Since you never want to scale images up and damage the image quality, you'll need to supply the largest image size that your layouts might require. This means that you'll be asking mobile devices to download larger images than they need and then scale the images within the browser. Both of these actions will harm performance on mobile devices and are less than ideal. If the image is purely decorative and not really necessary to the structure of the page, you could serve the image as a background image. By doing that, you could place requests for separate background images in each media query, ensuring that you're requesting only the image that you need for the proper device. This allows you to not only control the image's size, but also the image's context. If you're scaling an image down with a lot of detail, for example, that detail will often get lost as the image gets smaller. By serving a separate image for smaller layouts, you can crop the image or modify it to convey the right visuals for the appropriate space. In many cases, this solution works great, but it's not without its problems either. It's limited in that it can only work for images that don't need to be in the actual HTML. For images where accessibility is required or that fit within the context of the HTML, this technique won't work. It's also worth noting that in earlier versions of Android, all of the CSS background images would be downloaded, not just the ones needed for the appropriate media query. Now, this has since been fixed in Android, but it will create large resource downloads for users on older Android devices. If you're looking for some more robust options, there are a few solutions that have been created to utilize JavaScript or server-side scripting to examine the page, determine the context, and then serve the appropriate image. The Filament Group has a fantastic client-side solution that they dubbed Responsive Images, and you can check that out at their GitHub repository. Essentially, you just modify your htaccess file, link to their Responsive Images JavaScript file, and add a query string on any image that requires a larger desktop version of that image. The script will then parse the page and replace the smaller images with the larger ones when they're appropriate. There are many solutions like this one that have been developed over the last couple of years, and most of them share this basic approach. Have a script determine the context, then parse the page and serve the appropriate image. As with our other techniques, these solutions have their share of problems as well. First, They're a little bit more complex than a pure HTML or CSS solution. The JavaScript parsing can slow load times, and often replacement images are requested after the original image is already downloaded. That brings us to perhaps the biggest downfall of these types of techniques, and that's the evolution of browser prefetching. In an attempt to speed up page loads, browsers have begun to employ look-ahead prefetchers to request and download page assets before the HTML has finished loading. This means that any technique that attempts to parse the page and replace assets will be replacing assets that, to some degree, have already been downloaded. Essentially, all this means that while we do have some choices currently in making our images work within responsive designs, the current solutions are far from perfect. In our next movie, I want to delve further into the problems behind responsive images and a few of the solutions that are on the horizon that you'll need to keep an eye on.